Moving along, we're now getting into probability type questions. And here we've got an experiment, which just means we're flipping some coins or rolling dice. Two fair, distinguishable dice are rolled. So remember, this is from the lecture. There was a green dice and a pink dice. That's how we can distinguish the difference. And so if there's two different colors, a 1 and a 2 is different than a 2 and a 1. Again, I should have, we'll make one green. We've got a red dice and a green dice. So here those are physically different, so you've got to count them. So whenever we're doing anything with dice, it's always going to be a 6 by 6, right? You think, I'll do this. This might be a little bit boring or long for you, but if you got this right, you probably aren't watching this. So the way you could construct this, let me get rid of these if you needed to construct it, but after you construct it once, it's usually pretty good to see. So we could get a 1, a 2, a 3, a 4, a 5, or a 6. That's what we could get on the first dice. Second dice, we could get a 1, a 2, a 3, a 4, a 5, or a 6. Now watch this. This is sort of the way I haven't done this yet for you all, but what I'm going to do now is I'm going to make a table of the sums, because that's what we're using, right? Everything, they want the sum of the dice. They don't want that a 5 was rolled. They want that the sum of the dice. So it's a 4 and a 1, a 2 or a 3, right? So what I do is okay, 1 and 1 are 2, 1 and 2 are 3, 1 and 3 are 4. Notice you can just 4 and 1 are 5. Look at this pattern that develops. 1 and 5 are 6, 1 and 6 are 7. And I come back here. 2 and 1 is 3, 2 and 2 is 4, 2 and 3 is 5. They keep going up by 1, but sometimes you have to think 2 and 4 is 6, 2 and 5 is 7, and 2 and 6 is 8. And so as you get going, oh wow, I just really 3 and 1 are 4, and then this is going to be 5, 6, 7, 8, and 9. 4 and 1 are 5, and then you just kind of count 6, right? Because you're upping by 1 each time. 7, 8, 9, 10. 5 and 1 is 6, and then you get 7, 8, 9, 10, 11. And I'm just counting here because that's a lot easier. But 5 plus 5 is 10. You could check me on this. But the addition part, I start messing up. 6 and 1 are 7, and then you could just keep adding 1, 7, 8, 9, 10, 11, and 12. And we've got them all here. And this makes a lot more sense. And then now they want to know how many are 5s. Well, your 5s, you see them right here on the diagonal. Now, the textbook, they showed just the dice, the pairs of dice or the pairs of numbers. You don't necessarily see it, but you see your 5s are right here. 1, 2, 3, 4. So there's 4 5s out of a total of 6 by 6. This is, if you thought of this as a matrix, there's 36 different things in there, right? 4 5s. This reduces down. 2 goes into both. Actually, 4 can go into 36 as well. So 4 goes into 36. Is that 9 times or 8? 8 is 32. This is 9 times. So 1/9 is our answer. But more importantly than that, I don't know, more importantly, but what you want to notice is once you've done this once, you see this pattern, and you see the one that's going to be the biggest is sort of this diagonal of 7s is the most frequent thing that can happen. 7s can happen 1, 2, 3, 4, 5, 6 different ways. And then 6s, 1, 2, 3, 4, 5. 6s can only happen in 5 ways. And we saw 5s happen in 4 ways. So just like you made this, you incremented up. And if you come off the 7s, you increment down. 4, there are 3 ways to get a 4. There are 2 ways to get a 3. And there is 1 way to get a 2. And so these you could just, okay, how many ways are there to get a 2? Subtract 1, you get that. How many ways to get a 5? 5 minus 1 is 4. How many ways to get a 7? 7 minus 1 is 6. And then the other side is a reflection of what's going on. So how many ways of an 8? 1, 2, 3, 4, 5. So it sort of works the same way, but it's going up this way. So 7 was 6, and then you just, either way you're going, you subtract 1 for each step off, right? So there's 5 here, 4 here, 3. You see the 10s. There's 3 ways to get a 10, 2 ways to get an 11, 1 way to get a 12. But if we haven't done this before, I should have done this right off the bat, but anyway, we didn't teach. If we were really getting into the probability of dice, I would have done it this way, because once you do this, you see the patterns, you don't need to recount again. Probability of B, getting 5s, getting a 5 is 1/9, and there it is, answer from the answer key, right? Checks.